In this video, we're going to talk about memory layout in the FX3 device as being used by C or C++ projects. As a starting point, I've taken the UVC in memory project that we've played with, which is written in C, and another example which is over here in the basic examples of the SDK, which is called bulk loopback, which is in C++, and I just put them into a table to be able to easily follow that, and a graphical representation of the various blocks. And also you can change numbers here, you can play with the sizes of different things, and the table will update, and you can actually change the layout to match what you need. You can easily get to this table, it's publicly available, the link is in the description. And now, so a very quick description of what we see here is there is a standard instruction tightly coupled memory block, which we don't touch. That's where interrupt vectors basically live. That's a special memory dedicated to an extremely fast real-time response to the events. And then the user, so to speak, area starts at this address, which begins with the area for USB descriptors, which you may or may not need to increase or decrease depending on your needs. There is a general code area, which in one project, in C project, is only using 180 kilobytes. In a C++ project, they dedicated to 56 kilobytes to this area. There is data area for your like static variables, basically, and areas specific to C++, which are for C++ exceptions. And this RT compiler heap is a little bit, I think, misnamed. It's essentially the area where mallocs and news will be getting their memory from. There is a driver heap, which is used by Cypress library, basically. Buffer area, which is for DMA buffers to transfer data between USB and other various devices like FX3, for example, or FPGA. This is where the user space memory limit is. And then in C projects, there is a space for the two-stage boot. 32 kilobytes are dedicated to that. And in C++, it's not specifically specified, it's not allocated specifically, but if necessary, it can be done. For example, we can reduce the amount of code area by 32 kilobytes, so that's going to be 224, right? And then we can just add this over here, and there we go, our memory is back in place. To make my life easier, this same table is also in a protected template, so I know where the baseline is. This table will be publicly available but not publicly editable, so if you want to play with it, just make a copy of it, either download it as a Microsoft spreadsheet or just copy it into your Google Docs account, however you like to use it. Where are these numbers come from? How to get them, how to set them, and how to configure your project. First, we're gonna look into the C side of things, for which we can probably just go with our Visual Studio. So what we're gonna need is to look at the loader descriptor script and the cyfxtx.c file. These are the two files of interest for us. And let's start with FX3LD. The linker descriptor script. This is a comment which sort of describes things and where to find things to change appropriately. But what we are gonna look is not the comments per se, but the file itself. So this is our tightly coupled memory for instructions. We specified where it starts from and what the size is. That one we do not touch. This is our generic memory area, so to speak. So the sysmem is over here. If you can see, that's where the starting value, the origin is, and that's the length of it, which corresponds to this 180 kilobytes of size. And the data is also over here, and this is what specifies the very globally the layout of the memory that is going to be used. I'm not going to spend any time on this in this video. That's going to be covered in a different video, because there is a lot to discuss here. What we're gonna switch our attention to is this file cyfxtx.c, which is also coming from the Cypress SDK. Essentially, it has in a C version, it supports both 256 and 512 kilobyte devices. So let's just collapse the 256K because we are interested in 512 version. And again, skipping the comments because they do get outdated easily. When people change these numbers, they don't go revisit comments. This is just the default setting over here. But this is where we see the numbers that are specified in here. The memory heap base, memory heap size, and system memory top. This system memory top is essentially what limits our user memory, so we don't step onto the two-stage bootloader, which is specified over here to have 32 kilobytes. And these numbers are here, here, and over here. That's essentially all you need to change if you were to modify the memory layout for your C project. For the C++, we will go here into this bulk loopback project, and the corresponding cyfxtx.cpp file would be one thing. Let's just move this over here and this over here. And again, so for the C++, at least for the bulk loopback, Cypress does not define the memory layout for 256. They just say, nope, don't support, whatever you want, just don't use C++ in 256. I don't know why. There is no real reason for that from my point of view, but that's what they're doing. Probably because they decide that exceptions are a good idea to use in C++ version, and the new and delete left and right for the system, for the STL, for example, growing containers or strings. For whatever reason, they just said, no, 512 is the only configuration you want. And then the things that you configure are basically the same. There is our heap base, heap size, memory top. What is different, however, is this, where is it, common? If you go to common, this is our linker script, FX3 CPP LD. And here, if you look at that, you will see an extra ARM. So let me now, we do need to have a little bit more space here, just for comparison. So ARM is something that was not in a C version at all. This is where the C++ exceptions will be going. And there is also a heap start and heap end symbols, weak symbols, which are defined down, there we go, heap start and heap end. And this is all you need to know about setting up the memory for C or C++ project. Again, you go to this table, you play with these sizes that you want to change, like to 40 kilobyte here, for example, and that gives you 16 more K that you can add into, I don't know, data area, like, so it's like 36K now. There you go. And you can just play with these numbers, and you visually see where do you spend your RAM, and where, if necessary, you can trim some fat. Obviously, you always need to be careful about where you can trim some fat and how much of that you can trim. Most useful tool for that would be the map file, which is produced during the build. time, but I'm not going into that now. You can look into my file on your own and see a lot of information there, and there are some online tools that allow you to look through the .map file and figure out what's in there. And this is it for today. In the next video, we'll be moving our build system from GCC into G++ in preparation to moving all the way to Clang. And with that, thank you for watching. I'll see you in the next video.